All right, I'm going to do a couple of practice problems on Lewis structures. Remember, you need to follow step by step the rules until you become comfortable. So let's look at the first one. Let's look at sulfur trioxide. It's SO3. We do not have a charge, so we do not have to worry about that. What we must first do is add up valence electrons. By adding up valence electrons, we know that sulfur has 6, and we only have 1 atom of sulfur. So there's 6 electrons, and oxygen has 6, and we have 3 atoms. So that's 18 electrons. So when you add these together, you will receive 24 valence electrons to work with to build this Lewis structure. We know that sulfur is going to be the central atom when we're dealing with these multi-oxygen compounds. So we put sulfur in the middle. We then create 3 bonds, 1 to each of the oxygens. And those 3 bonds use up a total of 6 electrons, 2 electrons in each bond. That now leaves us with 18 valence electrons. We put the 18 valence electrons on the most electronegative atoms first until we fulfill octet. So those go around oxygens. 2, 4, 6, 8, 10, 12, 14, 16, 18. We have now used all 18 electrons to fulfill octet on the most electronegative atoms. We have 0 valence electrons left. We cannot add anything else to this structure. Now we must reevaluate if all of the atoms involved in the structure have octet fulfilled. And currently, the sulfur does not. So what we can do is take a lone pair from the atom with the most lone pairs and create a double bond to the central atom sulfur that does not have octet fulfilled. In this case, all of the oxygens have the same amount of electrons, so we can pick that lone pair from anywhere. So let's take it from this particular oxygen. So now we have sulfur double bonded to this particular oxygen, single bonded to the other 2 as such. And now we have octet fulfilled on sulfur. Now we must look at, do we have formal charge? Sulfur is currently associated with 4 electrons, and those 4 electrons are shown within those 4 bonds that it has around it. Sulfur normally has 6, so if we want to look at formal charge for sulfur, sulfur normally has 6. Right now, it's got 4, so 6 minus 4 is going to give us positive 2. So that means sulfur's formal charge is 2 plus. Formal charge on these 2 oxygens that are single bonded are equal to, oxygen normally has 6, it currently has 7, that will be a negative 1. So therefore, these oxygens have a formal charge of negative 1. Notice that the overall net charge of this molecule, as we have written it, is 0. And that's what we should expect, because if you look up, SO3 does not have a charge associated with it. But remember, the best Lewis structure minimizes formal charge. Therefore, if we can minimize formal charge on all of the atoms or on some of the atoms, then we will be making a better Lewis structure. Since sulfur is in the 3rd period or lower or higher, if you will, 3rd period or higher, then sulfur can have an expanded octet. So use that expanded octet in this particular case to minimize formal charge, create double bonds, and the creation of those double bonds from these 2 oxygens will minimize formal charge on all atoms, leaving you with the best Lewis structure for sulfur trioxide that involves double bonds to each of the oxygens, octet fulfilled on all atoms, and no formal charge. Step by step on how to draw a Lewis structure, to fulfill octet, minimize formal charge to get your best Lewis structure. Ion. carbonate. All right, let's do another Lewis structure example. This time let's work with a polyatomic ion. Carbonate, CO3 2 minus. Remember that first thing we need to do is determine the number of valence electrons involved in our structure. Carbon normally has 4. We have 1 atom of carbon. Oxygen only has 6. We have 3 atoms of oxygen. That is 18 valence electrons and 4 valence electrons. You add these together, you get 22. Now, this 2 minus charge that is shown on this polyatomic ion tells us that we have 2 extra electrons. So we must add those in to get the true total value, which is 24 valence electrons. That's how many we have to work with. Now, carbon likes to be in the middle of things. It likes to be the central atom. So the first thing that we should do is create 3 bonds to oxygen using 2 electrons each. That will use up a total of 6 valence electrons. That will leave us with 18 valence electrons left. We place those around the most electronegative atom, in this particular case, oxygen. 6, 8, 10, 12, 14, 16, 18. We've now used all of the electrons. We cannot add any more electrons to this structure. Now, we must evaluate, do we have octet fulfilled on all atoms? And we do not. Carbon does not have an octet. We must take lone pair electron from the atom with the most lone pair electrons and create a double bond. In this case, all of the oxygens have the same amount. That will leave us with a double bond to this oxygen, single to the rest. Now we have octet fulfilled on all atoms. We now need to look at formal charge. So the formal charge for the carbon is going to be equal to 4 minus 4, which is 0. And the formal charge on the 2 oxygens that are singly bonded are going to be 6 minus 7, which equals negative 1. So we have a negative 1 charge on each of the oxygens. We notice that the net charge here is exactly what we should expect it to be because of our original structure, CO3 2 minus. So we have our 2 minuses. Now, we should look and see, can we make a better Lewis structure by minimizing formal charge? And we cannot. In this particular case, if you were to make a double bond between 2 of these oxygens, what you will see is that you have not minimized formal charge. Now carbon would have a negative charge and oxygen will have a negative charge. But wait, even more important is that we cannot expand octet on carbon because carbon is not in the 3rd period or higher. So that is no good. This is the best Lewis structure here, and that is also shows resonance in 3 resonance forms where the double bond will be associated with the other 2 oxygens.